Hello and welcome to this interactive lecture on training validation test split. To come to the interactive dashboard, please go to the course homepage, which is gornikdata.com. And here you can find the link to the interactive dashboards. So please click on this button. In here you can see all the different interactive dashboards that were created up to now. And in this lecture, we will focus on the train validation test split. So please click on this link. So what you can see here is some Shiny application. So Shiny is a package of R, which is enabling you to create interactive dashboards. And you can see here there are many different inputs, like the data count, the train ratio, validation ratio, and some more, and we will cover these right now. The first parameter is the data count, and you can modify the data count between 10 and 1000. So we can do this. Click on 10 and you can see all the other bars are affected. Basically the table of the output was modified, the data count was adapted accordingly. And as a default, I set the training ratio to 60%. So we have here the slider for the training ratio, and you can see as we move it up and down, the bars are modified accordingly. And the same holds for the validation test ratio. So the residual between 50% and 100%, so we are keeping 50% left for the validation and test data. And in here we reserve right now 30% for the validation and 20% for the testing. And you can see the overall group of the data was adapted accordingly. The first parameter I want to draw your attention on is the selection type. So you can see we have here linear and random. Linear is what you can see right now. That is the default I started with because that's easier to understand. Right now we have set the training ratio to 50%. That would mean that the first 50% of the total data frame is used for the training. Then we have 30% for the validation reserved. That's the blue box in here. And the residual 20% will be used for testing. But I hope you can see the problem with this, because this approach has some underlying assumption in it. And the assumption is that the data is completely random in your data set. Imagine you want to create some binary classifier where you have some class A and class B, and your algorithm should be able to predict whether a certain combination of independent parameters is referring to class A or class B. And all the data of class A is to be found in the first 50% of your data frame. That would mean that your training data is trained completely on class A. There is no class B in it. And of course, the algorithm will predict that class A is the outcome. Of course, there was nothing else learned, so there is no point. And the residual data, which will be used for validation and testing, this is holding all the class B values. So in the end, you would have developed a completely useless classifier. And for this reason, you should always use some random selection of the data. So we do this right now, and it has to be understood in the following way. We still have the ratios, 50% for training, 30% for validation, and 20% for testing. And the data is now sampled randomly of the data set. So we now have sampled 50% of all data to be training and 30% for validation and 20% for testing. So that's important that you take the random selection for your data rather than some linear approach. And the next important parameters are the split ratios. So the question is, how should you set the split ratios for training, validation and testing? That depends on the total number of the samples and the actual model that you want to train. Some models require more training data than others, and in general, the validation data should be big enough to detect differences between the models. Models with few hyperparameters will be easier to validate and thus need a smaller validation dataset. And contrary, models with many parameters will be harder to validate and thus require a larger validation dataset. Let's take a look at an example. So let's say we have 1000 data and you want to have 200 datasets for each, for validation and testing. So you would reserve 20% for validation and 20% for testing. So let's do this accordingly. Here you can see it in the table. We have now 60% for training, which means 600 data sets are reserved for the training and 200 for validation and 200 for testing, because that's the minimum count for the data we want to have for validation and testing. But what happens if your data count is now increased because you gained more data or just got a larger data set? That has a very good impact, because then if you still want to stick to your minimum requirement of the validation and testing of 200 datasets, then you're able to increase your training ratio significantly. So you can increase the slider all the way up to 96%. So there is 4% left for validation and testing, and we can split it in half so that we have exactly 2% for validation and 2% for testing. So you can see the Shiny application was updated and we can see the final result. Here are the ratios, 96 for training, 2% for testing and validation. And with this increased data count, we now are able to decrease the ratios significantly and still get the required minimum data count of 200 for validation and testing. So that's what I wanted you to understand. Now it's up to you. Just go to the site, open up the application and play with the data. Have fun with the tool. Thank you very much and see you in the next lecture.